Hello and welcome to the Daily Space for today, Monday, September 14th, 2020. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain. Today has one story, and only one story. But it is the kind of story where I want all of you to look around and put into your mind where you are right now. Because this may be the first day we really admit that there could be life elsewhere in our solar system. Today, a peer-reviewed paper was published in the journal Nature Astronomy, announcing that a molecule considered to be a biosignature for life has been found in the atmosphere of Venus. This molecule, phosphine, phosphor and 3 hydrogen atoms. It has no known naturally occurring sources capable of creating the amount of phosphine that's being seen other than anaerobic life. The implication is there is chemical evidence of life within the atmosphere of Venus. Such a finding had previously been theorized down to the prediction of phosphine. Observational confirmation of these theories now comes to us from both the Atacama Large Millimeter Array and the James Clerk Maxwell Telescope. Jane Greaves is lead author of this work. Since the 1990s, NASA and other funding agencies have supported researchers who are trying to define the observable signatures of life in all its stages, from chemical imbalances in an atmosphere to technological signatures such as infrared excess. Researchers have put out paper after paper stating, if you see these things, life has probably found a way. Phosphine is a chemical that on Earth can be created through industrial processes, but naturally occurs only as the byproduct of anaerobic life, life that thrives without oxygen. It is created through the breakdown of organic materials. It's thought that phosphine in modest amounts will be detectable out to order of 10 light years, allowing life in the atmospheres of warm gas giants and other gassy that will allow, life in the atmospheres of warm gassy atmospheres of other planets to potentially be detectable using the James Webb Space Telescope. While this observation will be challenging, taking up to 10 hours or more of telescope time, it is doable. Here's the thing. Phosphine requires an atmosphere, but it doesn't require an atmosphere in another solar system. So while people have been figuring out that phosphine can be used to find life in other solar systems, other researchers, including the Planetary Science Institute's own David Grinspoon, the Massachusetts Institute of Technology's Clara Sousa Silva and Sarah Seeger, and NASA's David J. Smith, they've all been part of research looking at the possibility of phosphine producing life, being produced by life in the atmosphere of Venus. In recent months, we've seen paper after paper and popular article after popular article on this topic, on the topic of possible life in Venus's atmosphere. Now, that said, I have to admit, I haven't read any of those articles because I, for one, was in the there is one place that there can't be life and that place is Venus camp. It appears I lack creativity in my own thinking. This means I'm playing a whole lot of catch up on the science behind this story. These papers, they all made careful predictions based on some simple facts. Venus has a mean surface temperature of 737 degrees Kelvin. That's 464 degrees Celsius or 860 degrees Fahrenheit. At an altitude of 47.5 to 50.5 kilometers, those spacecraft melting temperatures, they drop so that at that higher altitude, the temperature is just 60 degrees Celsius and the pressure is 1 atmosphere, the same pressure that we have here at sea level on Earth. At lower levels down in the atmosphere, things, they ramp up, they get worse. But that mid-altitude temperate region allows us to begin to imagine a potential cycle where life has the ability to be billowed up, microbes, billowed up through gravity waves, waves in the atmosphere of Venus. And then as they rise, they seed moisture around them. And as the amount of moisture grows within this moisture, life can do life things until eventually the droplet gets too big to be supported by the air and gravity begins to pull it down. Now, the way this gets imagined is you have down at the lowest levels, 33 kilometers, a temperature that is capable of desiccating any life that gets down there. At this lower point in the cycle, you have spores. These are in the haze layer of Venus that we don't really understand. And then rising up out of this haze layer, those spores, they collect moisture around them. And as they rise and as they build that droplet, the spores come back out and they're capable of going through their biotic processes of replication. Eventually, their droplets get too big, they begin to fall down. As these droplets fragment, the life desiccates back down to the spores. This is a life cycle. Now, this isn't the first work to consider the possibility of life on Venus. This is just the first work to predict phosphine, which has now been seen, and to describe a life cycle within this atmosphere. But there's been other work that said there could be life as an explanation to what we're seeing on Venus. Just over a year ago, the August 26, 2019 Astronomical Journal contained an article by Yan-Jo Lee and collaborators, and they pointed out that the dark albedo features in Venus's atmosphere appear to, well, not be explainable. According to Lee, the particles that make up the dark splotches have been suggested to be ferric chloride, allotropes of sulfur, disulfur dioxide, and so on. But none of these so far are able to satisfactorily explain their formation and absorption properties. Now, while Lee wasn't able to explain the dark splotches with these normal means, sometimes you have to look beyond chemistry to biology. And collaborator Limay notes that observations of these particles are showing that they're about the same size and have the same light-absorbing properties as microorganisms found here on Earth. These dark splotches, they were earlier pointed out by noted biophysicist Harold Morowitz and astronomer Carl Sagan as potentially being microscopic life. So here we have two radically different stories. We have today's breaking news of the observational detection of the predicted phosphine in Venus's atmosphere seen with two telescopes. And that phosphine exists in a large enough amount that it can't be explained via photochemistry, chemistry in the atmosphere driven by interactions with sunlight. It can't be explained in the amounts that it exists by geochemical processes within Venus, as far as we know. We see the paper from a year ago postulating that maybe the dark spots could be, well, microscopic life. This is all building on so many different things. And the frustration is that we can't go out and say anything definitively. But here's one final thought I want to put into your heads. Recently, our view of the history of Venus has begun to change as the possibility that 750 million years ago, it was capable of supporting life as we know it on its surface, that its climate was radically different, that there was liquid water seas. Something happened. Something triggered a runaway greenhouse effect that destroyed this world for most life. But let's consider 750 million years ago when that catastrophic event happened. What was going on our world? Well, at that point, we had single-celled organisms capable of coming together in colonies to form sponges. We had it 730 million years ago, the beginnings of comb jellies. We had life on this world. And it's possible that there was life at the same time on Venus. And that life, as that environment collapsed, maybe it's possible some of the microbes took to the air and found a way to keep on going. Because life maybe does find a way. Now, it doesn't have to be a story that goes that way. It could be there is geochemistry on Venus that defies everything we currently understand, and life isn't necessary. It could be there's photochemistry in the complex atmosphere of Venus that does things that we aren't creative enough to figure out, and life is not necessary. It's possible life formed in those clouds, originating there. This is something that can't happen in our world. Here on Earth, our clouds are wispy, they're transitory. There is no standing moisture layer in the Earth's atmosphere with persistent droplets capable of supporting life thriving in those droplets. We can't do this. But on Venus, there is that persistent moisture. There is that possibility. And we can't know, is this unknown chemistry, or is this potentially life not too distant from what we understand on Earth? We can't know what the solution is until we go there and we're able to somehow fly through the clouds and see in our samples the life under our microscope. Currently, there are no planned missions to Venus. Well, there's planned missions. There's no funded nuts and bolts being put together in the process of being built research spacecraft coming from a government funding agency. Rocket Labs is looking to do a 15 kilogram microsat. It would have, well, the capability of carrying 3 kilograms of instrumentation with it. So it's probably not going to be what we need to say, yes, there is life. Hopefully, these discoveries will motivate those spacecrafts to come in the not too distant future. This is a kind of amazing day. Today may be the day that we all look back on and say, this is when we first realized we may not be alone in this universe. And the place I thought most inhospitable in our solar system may be where that life is first discovered. All right, we're going to end here. Remember today, this has been The Daily Space. My name is Dr. Pamela Gay, and I wrote today's episode, ad-libbed today's episode, following on the footsteps of a press conference. Today's episode will be engineered by Ali Pelfrey, and show notes and images for today's story will be put on our website by Beth Johnson. Thank you for being here. We are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are here thanks to the generous contributions of people like you. This October 24th and 25th, we're going to be holding a 36-hour-long hangout-a-thon. This is designed to raise funds to cover our costs during the 2021 fiscal year. If you want to learn more or donate today, please visit our website, CosmoQuest.org, and look to the link to the hangout-a-thon. Thank you.